plus D, there was a situation of minus D. They are caused by horizontal rods, either divided or continuous. So combination, one will produce plus D, the other one will produce minus D. The combination of forward, aft, and athwart shape, divided and continuous rods. So we'll talk a little bit more about this. We'll see the effect. We had made a round जिसमें कि deviations हमने देखे थे. These are quadrantal deviations. For 90 degrees, of course, the deviation is something. Then it changes for next 90 degree, comes back to original sign in the next 90 degrees. So alternate hota रहता है. For 90 degrees easterly, next 90 degrees westerly, then easterly, then westerly, like this. It keeps on changing. So every 45 degrees, sorry, 90 degrees it is changing. But the change normally happens, the sine curve, if you see, the change happens only after 180 degrees, correct? एक साइन की वैल्यू 0 साइन थीटा फॉर एग्जांपल, थीटा 0, 90 पे मैक्सिमम, 180 पे 0, तो साइन चेंज होता है 180 के बाद. बट यहाँ पे 90 पे ही चेंज हो जा रहा है, मतलब 90 पे 180 का इफेक्ट आ जा रहा है, यहीं से साइन चेंज हो जा रही है. एंड दैट इज व्हाई हियर वी से दैट इट इज अ फंक्शन ऑफ साइन ऑफ द ट्वाइस द कोर्स. मतलब 0 पे तो 0 है, 90 पे 90 into 2 180, यहां से यहां में 180 डिग्रीज आ गया. अब यहाँ के बाद साइन चेंज होगी. फिर यहाँ से 90 डिग्री मल्टीप्लाइड बाय 2 180, फिर यहाँ से चेंज हो गया. सो इट इज द फंक्शन of the sine of twice the course. Please refer to the first formula that we had written for total deviation, जिसमें सारे coefficients को हमने include किया था. Please check it out. What does it say about the coefficient D? How is the, और definition में ही लिखा हुआ है यहाँ पे जो अभी आपने लिखा. How it is changing?
D sine 2 cos.
D sine 2 cos. That means twice the cos. So we'll discuss little bit more. We'll take a look at the plus D and minus D. We'll see the rods which are causing this coefficient, and we'll see how it is changing. The deviation is changing every 90 degrees. So we go to the board. Just one second. Let me set up the camera. All right. Board clear? So we had seen that plus D will be caused by two types of situation where there is a continuous athwarship rod or divided forward and aft. Minus D will be caused because of two conditions, either divided athwarship rod or continuous forward rod. So these are two different rods. This is one rod. Here also two different rods. This is one rod. So let us take the case of plus D when we have this case where we have one continuous rod athwartship oriented. So when we are here, the continuous rod, of course, is going to have the compasses like this. What is the kind of magnetism that will be induced in this rod right now?
So nothing.
Nothing. That means deviation is nil. And DF also is going to be not affected. But when we are going on this course, the compass like this, slight bit of red will be developed. Red will be developed here, and there is a red already on the compass. So what
Easterly
kind of
deviation.
deviation? Very good. So this is easterly. What is happening to the DF? What is happening to the DF? DF is reduced. क्योंकि ये तो मैग्नेट का पोल है, यहां से बाहर निकल के वापस आएगा, तो एक इधर को है, एक इधर को है. So both are opposing each other. So the DF is decreased. When we go on this course, this is maximum induction. This is also like this.
Yes, sir. Maximum DF.
Rather we should take it like this.
ये तो minimum होगा सर
यहीं पे
DF.
है, तो दोनों यहीं पे है. This also like this, the poles also like this. So in this case, what is the deviation? It is not pulling this side or this side. They are in the same line. So deviation is nil. What is happening to the DF? The DF is minimum. क्योंकि जो यहाँ पे केस था, एक लाइन्स ऑफ फोर्सेस तो अर्थ की ऐसे चल रही है, और इसका रॉड में तो ऊपर पॉजिटिव नीचे नेगेटिव है, या नॉर्थ एंड साउथ है, बट बाहर से जो निकलता है वो वापस ऑपोजिट डायरेक्शन में जा रहा है. सो अर्थ का लाइन ऐसे, उसका लाइन वापस. सो डीएफ इज मिनिमम हियर. When we go on this course, the compass will be like this. The athwartship rod will develop a red pole here, the red pole also here. So what will happen to this? What will happen to the DF?
So westerly.
Very good. Westerly, क्योंकि interaction होगा, इसको इधर को push करेगा. So this is now westerly. DF is reduced again. When going south, we have this athwartship rod. Again, nothing here. No induction in this because it is parallel to the lines of forces. So no effect. Again, here it is nil. The DF is how much? No effect. क्योंकि मैग्नेटाइजेशन हुआ नहीं तो कोई इंटरेक्शन नहीं है. नो इफेक्ट. जो कंडीशन यहाँ थी वही कंडीशन यहाँ. Then going on this course, the athwartship rod is like this. This end becomes positive or north. The compass is like this. So what kind of deviation? And what is happening to DF?
So easterly deviation and DF will reduce.
Very good. So deviation now easterly. The two poles trying to push to each other. So easterly and df is further reduced. On the course here, which will be the deviation again nil. Why nil? Because the compass is like this. The rod is developing something like this. Remember that we are talking about the continuous rod. So df will be minimum. क्योंकि दोनों एक लाइन में एकदम एक दूसरे का ऑपोजिट में आ गया तो df will be minimum. The lines of forces of earth like this coming out from red going to the blue end, and so compass is lying in the opposite field created by the soft iron. On this course, if we go, this one is positive here or north, this is negative or blue. Here we have this. So what kind of deviation?
Westerly.
Westerly.
Westerly deviation, df is further reduced. So what we are saying here, that for all these courses, the deviation was easterly. On all these courses from here to here is westerly. In this area, if you see, again it is easterly and again westerly here. df, directive force, was not affected on north-south course, but becoming minimum here. So most of the time it is minimum, less than the actual df of the earth. The induced magnetism is further reducing. So overall 360 degree में mean df का क्या होना चाहिए? Is it remaining constant or is it is going to be less or more? Mean df मतलब overall 360 डिग्री के चक्कर में जितनी टोटल वैल्यू आती है एवरेज वैल्यू, वो टोटल वैल्यू से अर्थ के डायरेक्टिव फोर्स की वैल्यू से कम होगा या ज्यादा होगा या बराबर होगा. Mean directive force is what we are talking about. I'm asking.
What, sir?
सर reduce होगा ना सर?
कम ही
Yes.
होगा.
Exactly. मान लीजिए x था यहाँ पे, तो इस दोनों जगह पे तो x मिलेगा, लेकिन बाकी सब जगह x से कम मिल रहा है. तो मेजर पार्ट वी आर गेटिंग लेस, मिनिमम हेयर. सो अगर पूरे सर्किल को देखें तो x से कम की वैल्यू एवरेज आउट करेंगे. अगर सारे मेन डायरेक्टिव फोर्स को अगर हम एवरेज आउट करेंगे तो x से कम की वैल्यू मिलेगी, क्योंकि मेजर पार्ट में कम होता है. सिर्फ दो ही जगह है जहां पे ये अफेक्टेड नहीं हो रहे हैं, नॉर्थ एंड साउथ पे. So mean df is going to be reduced.
सर ये थोड़ा एक्सप्लेन कर देंगे सर, ये डेविएशन नील कैसे आई ये नॉर्थ और साउथ में?
The rod is like this. We are talking about plus d. ये जो केस है, it is plus d का केस when you have a magnetic field because of continuous aquaship rod. और compass का course, compass का heading is like this. Is that correct or not?
Yes sir.
But we know that when the magnetic lines of forces are like this, the induction is maximum when it is along the line. The iron is along the lines of the force, it is happening maximum. When it is perpendicular, it is minimum or zero. When at an angle, there is partial development of poles. Correct? Remember this?
Okay, sir, got it.
So what is the situation here? Is it not this situation?
Yes, sir.
So that means no magnetism here. No
Yes, sir.
disturbing.
No, nothing.
So deviation is going to be nil.
Okay, sir.
Another case is again for plus D is when you have divided forward and aft rods, 1 and 2, two rods like this. So now make the diagram and do like this. Make the diagram, work out your problem, how it is going to be. What should be the situation of the deviation and directive force? Work out the solution. Are we getting somewhere? Yes, sir. Any progress?
Yes, sir.
Okay. No effect. NE for no effect.
सर ईस्टर्ली होगा ना सर उधर नॉर्थ ईस्ट वाले क्वाड्रेंट में.
Yes. उल्टा 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 उल्टा. So plus D की बात कर रहे हैं. These are divided or continuous these rods. Both of these are going to produce plus D, and that is going to result in this kind of situation. Overall mean DF का क्या situation है यहाँ पे?
सर ईस्ट वेस्ट में मैक्सिमम है और नॉर्थ साउथ पे मिनिमम.
ईस्ट वेस्ट में DF तो
DF means DF is no effect. साउथ
but
में
major part it is increasing.
yes sir.
या तो नहीं होता है या इंक्रीज हो रहा है. So mean DF will be पिछले केस में हमने देखा था या तो 0 होता है या कम होता है, तो ओवरऑल कम हो गया. यहाँ पे या तो 0 होता है या ज्यादा होता है, तो ओवरऑल मीन डीएफ बढ़ गया.
Increase.
ठीक है. Then we talk about the minus D. Minus D is caused by continuous forward and up rod or divided athwartship. दो कंडीशंस में. These are the two conditions of two rods which are going to cause minus D. And in the similar fashion, I think now you're smart enough, you can work it out how it is going to go about. So in one, again, in one condition, when we talk about the minus D, one condition, the mean DF will be increased, another condition, mean DF will be reduced. However, the deviations which are going to cause is going to be caused is उल्टा, जो ईस्टर्ली था वो वेस्टर्ली हो जाएगा, ईस्टर्ली होगा, वेस्टर्ली होगा, ईस्टर्ली होगा. Remember the notes yesterday that we had seen that the situation changes in case of this. In both the cases of this rod and this rod, the deviations will be like this only, but the mean DF in one condition will be increased, another condition it will be reduced. All right. So, what are these rods, by the way, in the ship structure? When we talk about these, what are these? These are girders, these are beams. When we have the ship structure, there are beams running across, and there are girders like this. If compass is here, these are the forward aft rods that we are talking about, and these are the athwartship rods that we are talking about. Mostly, number of these beams running athwartship will be more, continuous athwartship rods will be more, giving rise to plus D. The forward aft rods will be less in number, so in most cases you won't have the case of minus D. Reason? Mainly because beams are number more, one, and the girders are less in number and they are short also. So most cases you'll find that there is plus D and not minus D. But of course it can be, special cases can happen, but we should know that there is minus D and minus E. So how do we do the correction? अगर प्लस डी है तो definitely we have to produce a minus D to counter it. So that correction will be done by divided athwartship soft iron. This will nullify this. The divided athwartship soft iron will create, अभी जो हमने diagram बनाया, athwartship divided rods, what they are doing? They are creating minus D. So we can create this to counter the plus D, which is because of the beams that we have. जो continuous rods का जो effect है उसको हम divided rod से nullify करते हैं. So what we do generally, if we have the compass, we have two soft iron spheres placed in athwartship direction. Of course, this is divided. एक इस तरफ को, एक उस तरफ को, athwartship direction में divided हो गया. When the ship is, let us say, going like this, one end becomes like this, the other end is becoming like this. प्लस डी का केस था जो अभी जैसे अपने फर्स्ट एग्जांपल में देखा था. कंपास वाज हियर, देयर वाज अ कंटीन्यूअस रॉड, द बीम व्हिच वाज द कंटीन्यूअस रॉड. In this case, there was no induction in this. But will there be induction like this in these two cases? The rods, the beams are not getting magnetized, but here these two are getting magnetized or not? Yes, sir. I'm asking this question from a different perspective, which is leading to a question which is generally asked in the exam. Here, there is no induction in this, but these two will get induced like this or not?
No, no, sir. They should not.
No or yes? The soft iron ka one end will be positive, the other end will be blue and red, like this. Happening or not?
Yes, sir.
Okay. So what we said, that in this case, the deviation was nil. The DF, directive force, was not affected. In this case, the DF was not affected. But since there is divided soft iron, this also increases the overall directive force.
Yes, sir.
Right. So these soft iron, apart from nullifying the effect of plus D, they are also producing a desirable effect that overall mean DF is increased.
But
Soft iron,
still didn't get how this iron spheres will get magnetized in this condition.
why? Like this, there is blue pole of the earth here. अगर हम देखें तो there is blue pole here of the earth, red pole here, like this. So lines of forces getting like this will be created or not? We have seen always that when it is like this end becomes red.
बट ये तो आउटवर्ड शिप में है ना सर, इनकी डायरेक्शन सॉफ्ट आयरन की
तो क्या हुआ? मान लीजिए कि
तो फिर
जहाज
मिनिमम
आपका और एक रॉड हमने यहाँ पे रख दिया, तो ये पॉजिटिव होगा या नहीं?
हाँ सर, ये तो होगा.
लेकिन ये
तो
तो
यहाँ
होगा
पे
ना सर, लेकिन
ये होगा या नहीं? 1 सेकेंड, ये रॉड कहीं पे भी रहे तो ये वाला एंड हमेशा पॉजिटिव होगा या नहीं? मतलब नॉर्थ होगा कि नहीं रेड पोल?
यस सर.
तो अगर हमने इसकी जगह दो स्फीयर रख दिए तो ये वाला एंड पॉजिटिव होगा या नहीं?
सर फॉरवर्ड में होगा उसका.
यस, तो वही तो हमने किया था अभी, वही तो बताया था कि कंपास यहाँ है, द सॉफ्ट आयरन लाइक दिस, सो दिस टू एंड्स विल बी रेड.
ओके सर.
So the correction of the D normally present plus D is done by negative D, which is divided, which is done by divided soft iron athwarship oriented athwarship direction. What is the effect of latitude on the directive force. We know that these, we are talking about the horizontal rods, correct? Either continuous athwartship or divided athwartship or continuous forward aft or divided forward aft. In each case, they are horizontal. That means they are magnetized by H. All these rods will be magnetized by the H component of the magnetic field of the earth, correct?
Yes.
Now, if we are taking the situation, here H is 0, here H is maximum. That means at this place, all these rods will have zero magnetization because H is 0 here.
Yes, sir.
So there is no directive force for the compass and there is no disturbing force for the compass because of this rods that we are talking about. As we keep on going here, H increases slowly. So डायरेक्टिव फोर्स बढ़ता है कंपास के लिए, साथ में डायरेक्टिव फोर्स मैग्नेटाइजेशन बढ़ता है इन रॉड्स का. तो अगर H बढ़ रहा है और जो डिस्टर्बिंग फोर्स है, लेट अस से दैट डिस्टर्बिंग फोर्स F is like this. If we go up in the latitude, the H becomes less. Similarly, by the same amount, this becomes less. So earlier, if the deviation was this much, when we go upper latitudes, this is reduces, but this also reduces. Again, what is happening to the direct deviation?
Remain same, sir.
Remains same. That means there is no effect of the latitude change on the D. When H increases, the disturbing force increases by the same proportion. When H decreases, this also decreases. The result is that the deviation caused by them is same at all latitudes. The event deviation will be a factor of the total deviation, maximum deviation, then multiplied by sine of twice the compass course. As we have already seen that it is changing at every 90 degrees. That means if we want to follow the sign which is normally changing from 0 to 180 degree, but here it was happening at 45 degrees only. So 45 into 2 is giving the same kind of desired result. So effect of course change is that this will change as the twice of the compass course. D की वैल्यू कैसे मिलेगी? Deviation on northeast minus deviation on southeast plus deviation on southwest plus minus deviation on northwest divided by 4. We average out for finding out the D. The coefficient D maximum कितना है, वो चारों पे हम डिसाइड करते हैं एवरेज लेकर के.
सर ये ऊपर वाले फॉर्मूले में डी कोफिशिएंट डी है ना सर?
हाँ, ये कोफिशिएंट
उससे पहले वाला डेविएशन वाला.
yes, deviation given value of this, okay, deviation one this, we can say deviation due to D is equal to ठीक है.
Yes, sir.
All right. Since we talked about, थोड़ा सा बात किया था अभी हमने. So what happens when the ship is going like this? The soft iron, this end is becoming like this. But when the ship is going on this course, it is like this. When she is going here, it is becoming like this. Now, why we said that it is increasing the mean here? The compass is here, heading like this. Compass is here, compass is here. All right. The mean directive force here is not increased, it is reduced. क्योंकि हमारा lines of forces are like this. This will have an effect that it is coming from the red pole. The lines of forces are coming from the red pole and going into the blue pole. So इसका अपना magnetic field होगा, that is उल्टा. Understood? Clear है ये? That in this case df is reduced. Is it okay?
Yes, sir.
Yes, sir.
All right. Now in this case also it is kind of reducing.
Yes, sir.
But अगर देखें तो इस केस में the compass is to the broad side of the two magnets. जो ये मैग्नेट थी इसके ब्रॉड साइड में है कंपास, इसके ब्रॉड साइड में है कंपास. करेक्ट?
बट ये तो स्फीयर थे ना सर.
हाँ स्फीयर का ही है ये, इसको हमने बार मैग्नेट से कंपेयर कर दिया, so as to get that clarity of end on and broadside position. So north south heading पे what we are seeing, the DF is decreased, but in this case they are increasing the DF like this. Is this okay or not? ये चीज होगा नॉर्थ पे भी और साउथ हेडिंग पे भी. This situation is going to be either on north or south heading. It is DF is reduced. Here in this case the directive force is increased. See that the red end is having a blue end forward, the red of the compass is having a blue end forward. So this is the DF is increased. Is this correct or not? Say yes or no.
Yes, sir. With blue and forward, it will increase.
Yes, but what we see here, that this decrease, if it is x, if it is reduced by an x amount, the increase in DF is 2x. Why? Because this is end on position. The compass is end on position. That means supposing that we have a magnet here, the compass is lying end on here, the compass is lying broadside here. तो रिडक्शन अगर होती है तो एक्स अमाउंट हो रहा है डायरेक्टिव फोर्स का, बट जब इंक्रीज होती है तो 2x होता है. सो इन 360 degrees of rotation there is more increase than the decrease. Is that correct?
Yes, sir.
When it increases twice the amount as when it is reduced. अगर h को माइनस एक्स करता है ये, तो h को प्लस 2x करता है यहाँ पे. एंड सो ओवरऑल 360 डिग्रीज में अगर देखें तो मीन DF is increased. Is that correct? Is it logical? चुप हो गए आप लोग, कुछ बोले नहीं.
Yes, sir.
Anyone having doubt on this? Or is it understood now? This is a question which is asked in the examination. How the soft iron spheres increase the mean directive force? The question answer is like this, that on north south forces the DF is reduced on east west forces DF is increased. But the decrease here is if x amount, increase is 2x amount. So if we take the average of all the 360 degrees of rotation, there is less amount of reduction and twice the amount of reduction is the increase. Why? Because of end on position of the spheres in one condition, broadside position in broadside in this condition, end on in east west condition. So more increase than the reduction, and that gives rise to increased mean directive force. बढ़िया है जी। ऑल ओके। सब लोग शांत हो गए, कोई कुछ बोलता नहीं। दुखी हो गए हैं क्या आप लोग?
सर हाई लेवल अलार्म आ गया।
हैं? सब लोग दुखी हो गए लगता है। मेरे से मत दुखी होएगा। मैग्नेटिक कंपास से दुखी हो लीजिए तो हो लीजिए, मेरे से नहीं होएगा, क्योंकि whatever is there in that is what I am teaching here. Okay, pen and paper, please. Take out pen and paper. We have 5 minutes. We'll take down notes for coefficient E. All right. Coefficient E is the maximum value coefficient E is the maximum value of the quadrantal deviation of the quadrantal deviation which varies as the cosine of twice the compass course twice the compass course and is caused by a horizontal field and is caused by a horizontal field and is caused by a horizontal field at the compass position due to induced magnetism due to induced magnetism in horizontal soft iron situated symmetrically about a 45-degree line through the compass position we will make a drawing फटाफट 2 मिनट है और क्या हो रहा है? So here you can see this is a continuous from port bow to starboard quarter. This is divided soft iron oriented from starboard to port. Opposite of that is this. So basically these are D and D rods.
सर टाइम हो गया.
Yes, just noting it down. ये हो गया? Are you done? Finished?
Yes sir.
Okay, then we are done. We meet again in the next class, which is after lunch. We talk about this a little bit further, and then we try to close the chapter. Bye bye. Have a great day, all of you. Signing off.
Okay sir, thank you.
Yeah. Bye bye.